And for the Laplace transformation of e raised to negative at cosine bt, we have the proper integral of e raised to negative at times e raised to negative st cosine bt dt. And simplifying by loss of exponents, we have e raised to negative quantity s plus a times t cosine bt dt. And using the tic-tac-toe method, we have the derivative and the integral part. We have sine bt. The derivative of that is b cosine bt. And having the pattern of operations or signs, we have positive and negative. And the integral part, the integration of e raised to negative s, quantity s plus a times t, is equal to negative 1 over s plus a times e raised to negative quantity s plus a times t. Integrating it again, we have 1 over s plus a squared times e raised to negative quantity s plus a times t. And combining by crossing the derivative and integral part, we have derivative and the integral part. We have negative sine dt times e raised to negative quantity s plus a times t over s plus a, and derivative times integral part, we have negative b cosine bt times e raised to negative quantity s plus a times t over s plus a squared, with the limits of 0 to positive infinity. Now we have this following condition in substituting the limits of 0 and positive infinity, or a very large number, which we represent it by a. So if we have t approaches to 0, we'll have sine bt be equal to 0 and cosine bt be equal to 1. On the other hand, when t approaches to a very large number, or t approaches a, sine bt will be equal to 0 and cosine bt will be equal to 1. As well as when we substitute t as to 0, as it approaches to 0, we'll have e raised to negative quantity s plus a times t be equal to 1. And when t approaches to a very large number, to infinity, or to a, we'll have e raised to negative quantity s plus a times t be equal to 0. And evaluating our improper integral with our limits, we have 0 minus quantity 1 over a plus s times 1 quantity negative 1 plus 0. And we have introduced the value of y from our original expression of the improper integral of e raised to negative s plus a times t cosine bt times t, in order for us to easily simplify the algebraic expression. And by having the limits, we have on the other side, we have y quantity a plus s squared plus b squared over a plus s squared. So we have transposed y on the other side after simplifying the limits of our improper integral. And having this, simplifying this, and distributing our negative sign, the only remaining expression will be 1 over a plus s, which is equal to the y quantity a plus s squared b squared over a plus s squared. And equating it to with respect to our y, we have y is equal to 1 over a plus s times a plus s squared over a plus s squared plus b squared. And simplifying the expression by division rule of fraction or exponents, we have, we'll cancel this to, so we'll have a plus s over a plus s squared plus b squared. And so this is we have the Laplace transform of e raised to negative at times cosine bt is equal to a plus s over a plus s squared plus b squared, or simply equal to s plus a over s plus a squared plus b squared. And that is the Laplace transform of it function.